Well, welcome everybody. We're just going to talk a little bit today about fall protection, rope access, and regulatory compliance in the United States. This is a really timely topic for a variety of reasons, not the least of which is that regulatory requirements are changing in the United States as they pertain to fall protection. I wish I could tell you what those are going to be, but I can't. So we'll move on. When we talk about fall protection in the United States and building our systems as a qualified person, we have a lot of things on our mind. Obviously, we're concerned about the safety of the worker or workers. We have a budget, we have a time budget, we have a financial budget. We want to make things fit the environment. We want to rig well. There's a lot of things on our mind, but sometimes compliance can sort of slip out the back door. So we're going to talk today about how important compliance is as it applies to fall protection. Fall protection is a pretty big deal because it kills literally hundreds of thousands of people every year. And if you expand that to worldwide, the number gets absolutely ridiculous. So trying to resolve falls has been a really big deal in the United States and, in fact, worldwide. Falls account for over 12% of all fatal occupational injuries. You think about that, that's kind of ridiculous, especially when you look at the numbers, which we'll do in a moment, that show that that number hasn't really gone down in the last 10 or 15 years. And of course, falls are really, really costly for all of us, which isn't necessarily the driving factor. We really want to save lives because we want to save the lives, but money is a factor as well. OSHA has tried to address the matter. OSHA, as you well know, is the Occupational Safety and Health Administration. It was created by Congress in 1970 under the Occupational Safety and Health Act, and the goal of OSHA was to prevent work-related injuries, illnesses, and deaths. And since the agency was created, that's actually happened. OSHA has actually helped to reduce workplace deaths and injuries in a big sort of way. When we look at the fall statistics, though, we find that that doesn't necessarily hold true. The way that OSHA has done that is by establishing protective standards. They enforce those standards. And then they also reach out to employers and employees to actually assist them in being compliant. So it's not just a stick philosophy. There's also a carrot involved. OSHA and the state partners have about 2,100 inspectors, and that's how they enforce the standards. And in addition to those inspectors, they have discrimination investigators, doctors, engineers, standards writers, and all sorts of other technical people all throughout the country to help support the whole occupational safety and health process. The big question that I get a lot is, does OSHA really apply to me? And in most cases, I have to be honest with you, the answer is yes. OSHA has jurisdiction over pretty much all workplace safety in the United States, with the exception of federal government employees, city, state, and county employees, certain special interest groups or special employee groups that are elsewhere covered, such as flight crews, truck drivers, mine safety, ships, family members working on a family farm or a sole proprietor pretty much of any kind, and volunteers. So unless you fall into one of those categories, you are subject to OSHA. If you have employees, your employees are certainly subject to OSHA. OSHA does most of its enforcement through something called the General Duty Clause. The General Duty Clause requires employees to, quote, furnish each of his employees employment and a place of employment which are free from recognized hazards. So in doing that, we have to identify what those recognized hazards are, and we have to ascertain whether they're likely to cause death or serious physical harm. We're going to go into that as it applies to falls here a little deeper in just a moment. Before I do, though, I do want to mention that at least 24 states right now, as well as Puerto Rico and the Virgin Islands, have what are called state plans. State plans are where states adopt their own standards as well as enforcement policies. Most states will adopt standards that are pretty similar, if not identical, to the Fed OSHA requirements, but some of them actually have different standards that are applicable, and especially, again, in the area of fall protection, many states really have gone the extra mile to try to create criteria or standards that apply to fall protection to, again, reduce the incidence of injury and death in their states. In addition to the general duty clause, there's something called a specific duty clause. The specific duty clause basically just says that if there's an occupational safety and health standard within the Act, you have to comply with it. It's pretty simple. The hard part is finding it. There are so many requirements spread throughout the OSHA regulation that figuring out which things specifically apply to you can be very difficult. General industry is contained in 29 CFR 1910, which has a bunch of subparts that actually apply, that actually have fall protection requirements. There's subpart D, subpart F, there's things specific to powered platforms for building maintenance, vehicle-mounted systems, there's personal protective equipment requirements, there's a lot of special industries. Shipyard has its own requirements, excuse me, and as does longshoring. If you're in construction, which isn't really addressed in this talk, but if you're in construction, there's a whole nother set of standards that specifically apply to you, and the standards do differ. So if you're doing fall protection under one group of standards, they do differ from the other. Now OSHA recognizes that this is a problem, and they're working on it, and they are trying to resolve it. But until it does, it can be kind of confusing. The frustrating part, though, is despite all of these standards and despite all of these regulations and despite all of the billions of dollars spent over the last umpteen years to protect people against falls, falls still continue to dominate the injury and death statistics in the workplace. The main reasons, if you go through the OSHA fall incident reports, they're reports from things that have happened, they're fatal facts, if you will. The main reasons have to do with or are cited as having to do with infeasibility of fall protection for the type of work being done, improper use of equipment, or a failure to rescue. So those three things pretty much are the, I don't want to say excuse because that's the wrong word, but those three things are pretty much the reason that are given in most situations when injury or death does occur due to a fall. If you look at the actual number of fatal falls over the years, the average per year between 1992 and 2004 is about 300 deaths per year. That's the total number of fatal falls, and it includes even slips, trips, and falls on the same level. So separating out the fatal falls from height, we see that about 71% of those, or 213, an average of 213, were fatal falls from height over those years. Looking down the column to 2005, 2006, 2007, we see that the number isn't getting much better. In fact, for a while it actually got worse. 80% in 2005, 83% in 2006, and 75% in 2007 were were the number of fatal falls that actually occurred from height. So what's the deal? Why is that the case? There was a study done in 2003 that is pretty enlightening on this subject. These guys investigated almost 3,000 fall accidents that occurred between 1990 and 2001. And you might think, oh, well, gee, that's old data, and I guess in a way it sort of is. But it's kind of difficult to get away from old data when you're talking about falls because it takes us a while to compile the statistics. Anyway, there was about 3,000 falls studied in this project, and it was found that about 30% of them were attributable to inadequate, inappropriate, or a complete lack of PPE, and PPE being personal protective equipment, of course. And the big thing that was interesting is that in 1996, the OSHA PPE regulations were revised. So right smack in the middle of this study, or the time period of this study, the OSHA PPE regulations were revised, and between one and the other, there was no significant improvement in the fall statistics. We also have incidents of suspension trauma or suspension intolerance. This is a highly debatable topic and one that generates a lot of lively discussion in various environments. But we have seen incidents that have occurred due to asphyxiation while a person has been hanging in a harness at height due to failure to rescue. So is the problem suspension intolerance, or is this the problem of failure to rescue, well, we can talk about that all day long. But that is one of the things that occurs with people at height. And there's some studies that have been done on that, and you can see this after the presentation. You can come back to this slide and research these research projects, because all of them are fairly interesting. And then the last thing we look at when we talk about falls and the significance of falls is the significance of the harness attachment point. Marie Samfu, of course, did a lot of work on this early on in the 80s. There were a couple of other incidents or other studies that have been done, including a presentation at the Tech Rescue Symposium by Mark Denver. But what's come out of this is that the best attachment point for working versus falling versus waiting for rescuing versus self-rescue or being rescued are not necessarily all the same attachment points. In most situations, there's not a lot of excuse for a dorsal attachment point, but in the AMFU days, in the early days, the comparison that Marie Samfu made was with body belts, which is basically a single belt around the waist. He compared those with a dorsal attachment point, and of course the dorsal attachment point won hands down. There haven't been a lot of projects done with the sternal versus dorsal, except for one in France that it was done by the French EDF, and I think that Petzl has access to that study, but I haven't seen much information shared on that. So where does rope access fit with all of this? Well, fall protection kind of is a big all-encompassing topic. And so when we talk about fall protection, we're not necessarily just talking about fall arrest systems. When we talk about fall protection, we're talking about everything from guardrails to safety nets to fall arrest, positioning, restraint. So there's a lot of things that fall into the fall protection realm. No pun intended. What we're going to talk about today is primarily personal fall protection systems comprised of fall arrest, position, and restraint, including rope access. When we talk about rope access, we place it at about the middle of the hierarchy of control. Now, if you've never seen this hierarchy of control before, it's a really good way to assess your decision-making process for how to protect someone at height. The best route is obviously eliminating the hazard altogether. So that big block on the bottom is your preferred route. If you can possibly eliminate the fall potential, substitute the type of work being done, that's obviously your best protection. Passive protection is things like guardrails. If you have a guardrail, then theoretically people aren't going to fall off of the structure unless they climb over it. And then the next best thing would be restraint. Restraint is basically putting a person on a leash so that they can't possibly reach the edge or the fall hazard. And then, of course, fall arrest is near the top, and administrative controls is really one of the least desirable methods of fall protection. Administrative controls consist of things like a yellow line painted on the ground and telling people don't go past this line, or a safety lookout posted on the structure telling people to be safe. That's really the least desirable method of protection. When we talk about rope access, we tend to talk about rope access as being somewhere in the in or near the restraint category. The restraint category essentially prevents the fall from occurring in the first place, and rope access, because it is a double rope system, prevents the person from ever really entering what OSHA considers to be a fall hazard, a fall being anything more than about 2 feet. Your fall incident rate comparison, when you look at rope access, has been highly successful. Now, rope access statistics aren't really kept very effectively in the United States because OSHA doesn't have a specific SIC code for rope access. Someday we'd sure like to change that, but in the meantime, all we really have to go with for statistics is what we get out of the UK from places like IRATA. And so if you look at falls in the United States, just in 2008, let's look at 2008 as a number, we see that the Bureau of Labor Statistics says that there were 25.3 falls per 10,000 workers. There were about 8 falls per 10,000 workers in the United States during 2008. And so that's a significant number of falls. In the same year, in the UK, there were 1.3 falls per not 10,000 workers, but 100,000 workers. And I highlighted that just because I wanted to point out the difference in the way that we do our statistics versus the way that they do their statistics. They put their rate per 100,000 workers, and we put our rate per 10,000 workers. And so by the time you do the transfer and you move your decimal, in the UK, you're seeing that using rope access techniques, you have a much lower probability of falls or fall incidents. Well, why is that? We find that rope access in general, because it is so versatile, it makes fall protection more feasible. It makes protection of the worker more feasible. There are places where typical fall arrest or fall protection type methods that are more common or more addressed specifically by OSHA that just aren't really possible in certain places. Whereas with rope access, the versatility allows you to put it in various environments. We also find that the amount of training required for rope access workers really helps ensure proper use of equipment, not just use but also inspection and care. And then finally, rope access really facilitates rescue because everyone who is trained in rope access is also trained in self-rescue and partner rescue. So for those reasons, rope access really helps to facilitate safety in places that might otherwise be unprotectable. There aren't really any standards specifically for rope access, at least not yet. There are a lot of standards that are national consensus standards that apply to fall protection. You see ANSI 1264, A1032, I14, Z359. And those consensus standards actually have sections that do describe rope access methodologies. They describe rope access techniques, or I'm sorry, not rope access, fall protection techniques, with the exception of Z359. Z359 actually does address rope access specifically and will continue to do so in a big sort of way. The point that I want to make, though, is that ANSI standards are not law. If an ANSI standard exists for something, you are not bound to follow it in the same way that you are OSHA. You must comply with OSHA. OSHA is a federal requirement, but an ANSI standard is really just a guideline as to how to achieve OSHA regulation or how to meet OSHA regulation. The ANSI standards themselves are not law. That said, they do provide guidance related to worker protection, and in fact, some of the ANSI standards are named in the OSHA field manual, which is basically what their field inspectors carry around with them that tell them how to assess hazards in a workplace. ANSI standards can become mandatory through incorporation by reference. So, for example, certain OSHA regulations, such as CFR 1910-135, says that protective helmets purchased after July 5th, 1994 have to comply with Z89.1. So that means that since OSHA has specifically cited this standard, you really have to buy a helmet, have to use a helmet that complies with this standard. In most cases, when you are complying with an ANSI standard in order to meet an OSHA requirement, OSHA accepts the more current version of that standard. For example, Z89 has been updated, I believe, at least twice since the 1986 reference because ANSI requirements and ANSI standards are a lot easier to revisit and update than OSHA regulation is. So it's been actually updated since then, and OSHA will actually preferentially defer to the newer standard. In addition, you can be cited for not following voluntary standards. For example, in this case, the ANSI Z359 standard is not specifically cited by OSHA as being required. OSHA does, however, say that it's a good way to achieve their requirements, but it's not actually cited in the regulation as being a requirement. However, these inspection reports are actually incidents where where the Z359 document was named as criteria for the citation. And I'll give you an example here on the following page. This is what a the report looks like if you go onto the ANSI or onto the OSHA website. You can find these reports, and you kind of have to dig through them to find this kind of information. But you can see where ANSI Z359.1 2007 was cited as an acceptable abatement method or as a preferred method to whatever the person was doing. So even though they're not law and they're not required, if you follow them, you can protect yourself from citations. The other thing to be aware of when looking at standards is that if you don't follow a standard that's out there, you can be subject to civil or criminal liability, even if OSHA does not cite you. So, for example, if you injure an employee through some work practice and OSHA doesn't find you negligent due to an existing standard, that person or that person's family can still sue you, and they probably will cite industry standards as being the recognized industry best practice, and that's a really big deal. And for those of you who are listening who are also fire department and or rescue type people, that's an important thing for you guys too, because there are standards out there that are agreed upon by consensus by a large body of people, and if they're recognized as industry best practice, if you're doing something different, you really need to justify that. Industry best practice can come from industry standards. It can come from your own company's standard operating procedures, as well as just commonly accepted methodology. So it doesn't even have to necessarily be written down in a standard to be considered industry best practice. So where does that leave us for rope access? Well, with SPRAT, with the Society of Professional Rope Access Technicians in the United States, we really strive to achieve safety for people working at height using rope access techniques in compliance with OSHA, federal and state OSHA regulations. SPRAT uses a systems approach, which means that we include employee certification and selection. We consider equipment, communications, and rescue. All those things are part of the SPRAT process for ensuring safety at height for the worker. There's something called a SPRAT work plan or a permit, depending on what area you come from, and the permit can look something like this. Basically, SPRAT says that when you're doing work at height, you need to address these issues. The methods that are used, the member of the work team and their duties, the equipment that you're using for access, your hazards, your PPE, your anchor, your public safety, as well as rescue and emergency response. Now, sometimes people confuse the rope access permit or the rope access work plan with a JSA or a job hazard analysis. The two are very, very different. Although the job hazard analysis is part of the SPRAT work plan, the SPRAT work plan is more all-encompassing than a JHA. A JHA does not necessarily include all of these items. OSHA actually mandates work plans. They say that when you're doing work and it's a hazardous type of work, you need to state company policy. You have to have a site-specific plan. That means you can't just take a plan out of your pocket and use it for every place that you work. You have to be specific to that site, especially where it comes to anchorages and things like that. OSHA management responsibilities, what that means is who's your qualified person, who's your competent person, who's your authorized persons for work. The work plan has to address hazard identification, or the JSA. Again, that's one small part of the entire picture. The work plan asks for safety control measures. It doesn't necessarily say that the control measures have to be conventional or something that's recognized in an existing standard or even in OSHA regulation, but you have to address it and you have to tell why it's safe and why it's the preferred method. There's always an emergency and accident response plan. Training and communications is always an important thing, and record keeping pertaining to that training and communications, as well as to the rest of the kinds of work going on. And then there has to be a process for enforcement, not by OSHA in this case, but enforcement within your own company. How do you ensure that your employees are working according to your work plan? If you look at that, that's pretty similar to the previous slide, where we talked about the SPRAT work plan. The SPRAT work plan strives to emulate what OSHA specifically asks for in their work plan. So what are some common fall protection methods? Well, we talked about avoidance. Avoidance is avoiding the fall altogether. We talked about restraint. Restraint is putting a leash on a person to keep them from approaching the edge or the fall hazard in the first place. Positioning is hanging or being suspended in such a way that you're not necessarily using your feet for your full suspension or for your full force of your body, but you're protected against the fall. And fall arrest, again, is your least preferred type of protection because it does allow the fall to occur. So those are common fall protection or personal protective methods. Rope access, again, falls somewhere between restraint and positioning. So we consider rope access to be ideally done in such a way that it cannot permit the person to fall. And that's why when we're doing rope access techniques, we always say you need to limit your fall to 2 feet or less, and that keeps us within the realm of positioning. Again, that puts us in about the middle of the hierarchy of control. The hierarchy of control is a fairly commonly recognized tool for use by fall protection and safety managers. Rope access accommodates increased safety through training, pre-planning, reducing the amount of potential fall, using sternal harness attachments, the versatility of the system, and the redundant safety. So rope access is a good way to stay compliant with your fall protection requirements within your local jurisdiction, as long as you're performing those rope access techniques in accordance with your local jurisdiction. Rope access is commonly used by a wide variety of workers, everything from bridge inspectors to construction workers to theater and adventure park and of course wind turbine personnel. So rope access is fairly widely used across the board in both general industry and construction. Guidelines for doing rope access work can be found in the Safe Practices for Rope Access Work, as well as certification requirements for rope access work. Both of those can be found at the SPRAT website, www.sprat.org. And the SPRAT documents will provide excellent guidance for how to do rope access work, but you need to also understand your local jurisdiction, the requirements of your local jurisdiction as they pertain to whatever regulations that you're going to fall under, no pun intended, and you need to work within those requirements as well as within Safe Practices for Rope Access. There are other existing standards out there for rope access. There's actually an ISO standard. It's 22848. And that is a pretty broad-based rope access standard written by multiple organizations throughout the world. SPRAT was involved in writing that, as was IRATA, as well as the Norwegian, Australian, German, and South African rope access associations were all involved in that process. So rope access isn't just in the United States, and the techniques that we use in the United States are fairly similar to what they use throughout the rest of the world. So let's talk about compliance here for a moment. Compliance is the act of adhering to a standard or regulation, and not just adhering to it, but being able to prove that you're adhering to it. Compliance is something that you have to consider in terms of federal requirements, such as OSHA or the equivalent of OSHA if you're in another country, state, industrial compliance, so for example, your general industry versus construction, or your shipyard versus longshoring. You may have local compliance issues. Your local jurisdiction may actually have more strict requirements than state or federal. And then, of course, your company should have its own requirements that fall within the same requirement, or fall within the compliance capabilities of the rest of these areas. Rope access is actually addressed on one state level. It's addressed by the state of California in their code, and we're hoping that federal OSHA will follow suit. When you're considering compliance and trying to be compliant within your local area, a good way to look at it is to look at it the same way that OSHA inspectors look at it. The way that OSHA inspectors look at it, or are taught to look at it, is in the way that's outlined in their field manual. First of all, they have to identify hazard exposure. Hazard exposure can be any hazard that might exist. It can be an observed exposure, it can be an unobserved exposure, or it can even be a potential exposure. So what if? What if this happened? What if that happened? It might be something that you can't even necessarily see. So you as the safety manager for your organization really need to think through not just the existing hazard exposures, but the potential hazard exposures. Recognized hazards are those that have already been addressed within an industry or by an employer or even just through common sense. Recognized hazards occur within an employer when you have accidents or incidents that occur within an employment organization. So if something bad happens in your organization, if you have a fall or you have an incident, you need to take specific actions to prevent that from ever happening again, because that is now a recognized hazard. The hazard has to have existing potential for harm. So just because there's a hazard, if it can't create harm, if it can't do any damage, then it's really not citable. It's really not a big problem. So your potential for harm has to exist, and your feasibility for abatement has to be able to be existing. So it has to be possible to protect against that recognized hazard. So OSHA looks at it with those things in mind, so therefore you probably should as well. Some ways to do that is to align your work plan with OSHA requirements as well as industry best practices. So know which OSHA regulations apply to you and which industry best practices are most applicable to your type of work. When you're doing this, when you're looking at your work plan, think big picture. Don't just think fall protection, but think about chemical hazards that might exist or other things that might be problems or safety hazards within the area. Identify which ANSI standards that might apply to you. If they apply to you, you should incorporate them by reference, if possible, into your company plan. Use a reference list of some sort. And again, if you decide that you're not going to go with that ANSI standard or that existing even ASTM standard, if you're not going to do what's said in that standard, simply make your reasoning why, make your argument as to why in your work plan and show why and how what you're doing is as safe or safer than what's written in that document. And again, think about other issues other than fall protection, confined space, emergency response, electrical, dust, etc. Know that you don't have to be familiar with every standard out there, but if you're a safety professional, particularly a safety professional responsible for people working at height, keep abreast of important new standards that are happening within your industry. So the ANSI Z359 and A1032 and I14, those things are all evolving right now. All of those things have things happening in them right now, and you should know about those things. In addition, the OSHA general industry side of the house is changing their regulation. There was a big new proposed regulation came out several months ago, and that is in discussion right now as to how to update that. So be aware of that, be on top of that, and provide input to that as well. Consider outside perspectives. Just because you do something a certain way or have done something a certain way for a very long time doesn't necessarily mean it's the best way. Try not to become myopic. Know what's happening, know what other industries and other people are doing, because that is what might be used as industry best practice if ever you're called into question. Expand your employees' training and experience, and of course record that training and experience as it occurs. Professional affiliations can really help you stay abreast of what's happening. And if you use all of those things along with a continuous improvement process, you'll be pretty well covered. A good way to handle this is to have sample audits by an outside organization. Sample audits, especially in rope access, are not uncommon, and even in the fall protection industry are not uncommon, and can be a really good way to protect yourself against potential citations from regulatory authorities. Finally, if somebody does say that you should do something, if you do have an internal or an external audit and somebody recommends that you implement some sort of a standard or some sort of a practice, you should take that recommendation seriously, and you should either accept it or give a darn good reason for rejecting it and write that down. Always keep records. Keep records of your work plans. Keep records of your training, your personnel, their qualifications, the equipment that you use, the inspection and care of the equipment that you use, and again, that continuous improvement process. Safety and compliance are something that are in constant tug-of-war with one another, and it's something that that we really wrestle with in the fall protection field, because most of the situations that we find ourselves in are not necessarily cookie cutter. As a result, the best way to protect ourselves in the future is if the industry would discontinue reliance on compliance-based safety and acknowledge that there's more to safety than product design. We've historically regarded safety as being equivalent to products. If you use an ANSI Z359X marked product, you should be safe. That's hogwash. You need to use the product safely. So there's more to safety than just product design. Not all potential fall situations accept cookie cutter solutions. Again, that's where rope access really finds its niche. If we increase training requirements for everyone who works at height, not just rope access people, but everyone who works at height, it'll keep people from getting themselves into trouble in the first place. And we need to separate controlled descent concepts from rope access in the United States. OSHA tends to look at controlled descent as being very similar to scaffold work. Rope access has absolutely nothing to do with scaffold work. A rope access system is typically fully interchangeable. It's fully capable of using a main line as a safety line and a safety line as a main line, and dashing back and forth between the two as necessary. And so separating the concept of rope access in the United States is going to be a really important factor as we grow the fall protection regulations and requirements. And then, of course, different training levels for different complexities of work. Not everyone washing windows on the same building for 20 years needs to have the same level of training or the same level of expertise as someone who might be working on the atrium inside and doing metal refinishing work. It's a completely different world, completely different access techniques. We need to make allowances for those people who are doing repetitive type work and who may be using rope access techniques but don't necessarily need to maintain the high level of skills. And then finally, we need to consider an advanced rope access style harness in fall protection. Typically and historically, fall protection requires that dorsal attachment point, and we're finding that the rope access style harness that has the sternal attachment point is in many cases much safer, not just because you can check your own safety as you're clipping in and out and moving between systems, but also because of the position that it puts you in both during the fall and after. Some people complain that there may be a concern of things whipping you in the face as you're caught by your sternal attachment, but the reality of that is that when you fall and your system tensions up, your head goes backwards, your face and everything kind of move away from your point of attachment. So that's not really what happens in a real fall. So we need to explore all that kind of thing further, and I believe that NIOSH is actually undertaking some work in that regard as well. I'd like to thank you all for your time today. I hope this information was of some use to you, and if you want to talk about any of it any further, you're more than welcome to contact me directly at any time. I'd also like to pass along just the contact information for the Society of Professional Rope Access Technicians down there at the bottom of your screen there in Wayne, Pennsylvania, and they can be reached for any kinds of questions that you might have about rope access in general. Jessica, I'll turn it back over to you.
All right, give me just a second to change the screen back. Okay, so anybody that has any questions, there should be a box in your control panel that says chat/questions. You can type your questions in there and I will be asking them to Louie. And we do have a couple of questions already. And the first one is, what should I do if I'm cited by OSHA for using SPRAT best practices for rope access?
If SPRAT can't cite you, or I'm sorry, OSHA can't cite you specifically for using SPRAT safe practices, OSHA has to cite you against some regulation in their regulatory requirements. And so their regulation that they most commonly cite people against is that general industry requirement. The general industry requirement says that you have to keep people safe. So the onus is on you at that point then to prove that you're keeping people safe and to show how you're keeping people as safe or safer than what OSHA might say in some of their other regulations. So if you're cited by OSHA, for anything doing rope access work, you should contact SPRAT and ask them for assistance. We do provide guidance and assistance for people who struggle with citations, whether they're doing rope access or other suspended work at height. It's much easier to protect someone or help someone protect themselves if they are in fact using rope access techniques, because again, those techniques are more compliant typically than just your run-of-the-mill controlled descent system.
Okay. Next question is, how is SPRAT different from IRATA, and which organization does OSHA recognize?
That's a really good question. At this point, OSHA doesn't specifically recognize either organization, but the organizations are hugely, hugely different. IRATA stands for Industrial Rope Access Trade Association. As such, it is a trade association. It represents a trade, kind of like the Steelworkers Organization or the Welders Association. So it's representing the trade and the employers in that trade. As a trade association, the emphasis is on the employer and on increasing the amount of work and increasing the recognition of the employer. SPRAT is the Society of Professional Rope Access Technicians. As SPRAT, we are an individual-based organization. Our membership, and I forgot to mention that with IRATA, I'll go back to that in a minute. Our membership is basically comprised of anybody who wants to be a member. It's a full consensus organization. So in order to be a SPRAT member, you sign up to be a SPRAT member, and there are corporate members and there are individual members, and we represent all aspects of rope access from all different directions. As a trade association, IRATA's membership is comprised of employers, rope access organizations who employ rope access technicians to go out and do work. So it's a very different focus, a very different approach to industry, and it's just the difference between a trade association versus an industry organization.
Okay.
I should also,
can you go ahead?
Sorry, I guess I should also add that IRATA was initially developed in the UK. They are worldwide now, but they were initially introduced in the UK, and as such, they wrote their rope access practices based around the HSE, the Health and Safety Executive Requirements for rope access. So they really blended their work methods with the HSE. And I should point out that that is a struggle that we're finding in the United States as time goes on, because there are rope access people, there are IRATA technicians working within the United States who sometimes don't have knowledge of the U.S. regulatory requirements. SPRAT was grounded and founded in the United States, and our practices are based around OSHA requirements, but when we have technicians go to other places in the world, it again is extremely important to pay attention to those local and other country jurisdiction regulations, just because they do vary from place to place.
Okay, and can you expand a little bit on what you mean by administrative controls? It was at the top of the pyramid.
Yeah, administrative controls is a loosely recognized method that basically says that when no other method of protection is available, that you should at least have administrative controls in place to protect workers. Administrative controls include things that aren't physical barriers. So they would be such things as excessive training or extensive training for individuals working in a certain environment, or, as I said, a yellow line painted on the ground, and you tell people don't go over that yellow line. And it's really, if you're using administrative controls for protecting people at height, you'd better have a darn good reason that some other more viable and useful method won't work. Because even though it's acknowledged, it's really not a desired method because it's really not very effective.
Okay. And do you have any information on forces that affect the body in a fall in the dorsal versus the sternal attachment points?
You know, that's a really good question, and it's one that we really haven't done a whole lot of testing on as an industry, and we really need more testing. And the reason we don't have it is because it's really hard to get volunteers. There was some testing done, and it's outlined in The Fundamentals of Fall Protection by Andrew Solowski, which is a pretty old book now, but it refers back to testing that was done by the ejection seat manufacturers and parachute manufacturers back in the 1950s and 60s, and it kind of just extrapolates information to prove that the dorsal attachment is the better attachment. Unfortunately, at that time, seat harnesses and sternal attachment full body harnesses really weren't in vogue, and they really weren't used even in well, anywhere. They just weren't really used. And so as a result, there's not a lot of good data out there. As I mentioned, though, there was a study done by the EDF, the French EDF, which is their electrical organization, and that there was some great research done that basically showed that the rotational forces in a dorsal attachment are much higher because your center of gravity is actually closer to the front of your body than the back. So when you're attached to the sternal attachment, you're attached closer to the center of gravity, and your body rotates more evenly around the center of gravity or around the attachment point, whereas if you're attached on the sternal attachment, especially if you fall in a head-down position, which is what we tend to do as human beings. We tend to not jump off of things. We tend to trip and fall off of things, which puts us in a head-down position as we're falling. And so when we fall, when that catch occurs, we're typically in a head-down or a close to head-down position. And the rotational forces and the whiplash effect is just horrendous. Unfortunately, I don't have access to a copy of that study, although I desperately wish that it was something that could be released. But for a good way to try this for yourself is to put a harness on and attach yourself to the rear attachment point and dive off of something, and then try it on the frontal attachment point, and I think you'll probably see the difference.
Great. All right, and that looks like it's all the questions so far. If you have any further questions, you can go to the website shown on your screen, and there will be a link to email Louie. And at that link, you'll also be able to download the slides from this presentation and watch the live recording. Those will be up within 24 hours. The PMI webinar series hosts... Go ahead.
I should add that that last comment was facetious. I don't recommend diving off of anything.
I would agree with that. The PMI webinar series hosts a webinar on the first Tuesday of every month, so you can mark your calendar for December 7th at 12 p.m., and that's Mountain Time. You can keep an eye on the website for the topic. We try to keep these topics very up with what is going on in the industry at the time, so we keep them very recent. So we generally don't decide the topics until about a month out. So it should be up there fairly soon. And also, for more information on news and updates and about webinars and about everything going on with PMI in general, you can follow us on Twitter and fan us on Facebook, and our links are shown at the bottom of your screen. So we'd like to thank you for joining us for the webinar, and thank you, Louie, for doing it. It was very good.
Thank you for being here.
Have a great day, everybody.